A silent universe should not feel this loud. Across the darkness above us, there are billions of galaxies. Each galaxy holds billions of stars. Around many of those stars, planets exist in regions where life could, in theory, survive. Yet when we listen, when we search, when we scan the sky with our most advanced technology, we hear nothing. No signals, no messages, no clear signs that anyone else is out there. This silence is not just surprising, it is unsettling. For decades, scientists believed that intelligent life should not be rare. It should be expected. The basic ingredients for life are everywhere: water, carbon, energy, time. The universe has had almost 14 billion years to work with. That is an almost unimaginable amount of time for life to begin, evolve, and become intelligent. And yet something does not add up. If intelligent civilizations are even moderately common, then the universe should not be quiet. It should be filled with signs of activity, signals traveling between stars, evidence of advanced technology, even simple radio waves spreading across space like ripples in a pond. With enough civilizations, the sky should not feel empty. But it does. This contradiction sits at the heart of one of the most important questions in modern science. Are we alone, or is something preventing us from ever meeting anyone else? The observable universe stretches across about 93 billion light years. That number alone is difficult to comprehend. Inside that space, there are estimated to be more planets than grains of sand on every beach on Earth combined. Many of those planets sit in what scientists call the habitable zone. That is the region where temperatures could allow liquid water to exist on a surface. And where there is water, life as we know it has a chance. This is not speculation based on fantasy. This is based on real astronomical data collected from telescopes, space missions, and planetary surveys. Scientists have already confirmed thousands of exoplanets. Many more are strongly suspected. The numbers keep growing. With so many opportunities for life, intelligence should not feel impossible. In fact, it should feel almost expected. Yet there is a problem, a deep and growing problem. We have searched the sky for decades using radio telescopes. We have scanned nearby star systems for artificial signals. We have listened for patterns that could not come from natural sources. So far, nothing has stood out as clear evidence of intelligent life. This absence is not minor, it is complete. This is where the mystery begins to sharpen, because the universe is not just large, it is old, very old. Many stars formed billions of years before our sun even existed. That means if intelligent life is possible, it should have had many chances to appear long before us. Some civilizations, if they exist, could be millions or even billions of years ahead of humanity in development. If that is true, then why is there no trace of them? This question creates a tension that scientists still struggle with today. It is known as the Great Silence, a universe that should be active but appears quiet, a cosmos that should be filled with signals but shows none. And this is not just a casual curiosity. It is a serious scientific problem that challenges our understanding of life itself. Physicists and cosmologists, including Brian Greene, have explored this silence not as a small gap in knowledge, but as a fundamental clue about reality. If intelligent life is common, then where is everybody? If it is rare, then why does the universe seem so perfectly built for it? This is not a question that can be answered lightly. It touches on astronomy, biology, physics, and even philosophy. It forces us to consider uncomfortable possibilities about life, survival, and time. In this video, we will go deep into this mystery. We will explore why scientists believe intelligent life should be common across the universe. We will break down the Fermi paradox and why it challenges everything we expect about space. We will examine the idea of a great filter, a possible barrier that stops civilizations from reaching advanced stages. We will also look at the role of time, distance, and communication, and why these factors alone might be enough to keep us forever isolated. By the end, a simple question will feel much heavier than it does now. Is the universe full of life that we will never meet, or are we the only voices in an otherwise silent cosmos? Welcome to the channel. If you are new here, subscribe for more deep science stories that explore the biggest mysteries of existence. To understand why this silence feels so strange, scientists first look at something called the Drake equation. It is not a single answer. It is a way of breaking a massive question into smaller parts. It estimates how many intelligent civilizations might exist in our galaxy at any given time. The equation starts with something simple. The number of stars in the Milky Way, that number alone is staggering. There are over 100 billion stars in our galaxy. Many of them are older than our sun. Many of them are stable enough to support long-lived planetary systems. Next comes the planets. We now know that planets are not rare. In fact, they are the rule, not the exception. Almost every star seems to have at least one planet. Many have several. Some systems have Earth-sized worlds in what scientists call the habitable zone, where temperatures could allow liquid water. This is where things become even more interesting. The chemistry of life is not exotic. The basic building blocks of life, such as carbon, hydrogen, oxygen, and nitrogen, are found everywhere in space. These elements form in stars and spread through supernova explosions. They are present in dust clouds, comets, and even distant galaxies. Some of the most surprising discoveries come from deep space chemistry. Scientists have found complex organic molecules floating in interstellar clouds. These are the same types of molecules that on Earth are linked to the origin of life. This means the raw ingredients for life are not rare. They are scattered across the universe like dust. With all of this in place, many researchers once believed life should not be unusual. It should appear whenever conditions are right. Over time, life could evolve. On some worlds, it might remain simple. On others, it could become complex. And in a small number of cases, it could become intelligent. This is where the Drake equation becomes powerful. Even with conservative estimates, it suggests that intelligent civilizations could exist in large numbers, at least in theory. For a long time, this created an expectation. Scientists thought that if intelligent life was common, then the galaxy should feel active. There should be signals in the radio spectrum. There should be patterns that do not match natural sources. Some civilizations, especially older ones, could even be spreading across the galaxy, building structures or sending probes. In the 1960s, projects like SET, I began scanning the sky with this expectation in mind. The assumption was simple. If others are out there, their technology might be detectable. Even a single strong signal would change everything. But something unexpected happened. The more we searched, the quieter the universe became. No confirmed signals have ever been found. No repeating patterns that clearly point to intelligent origin. No evidence of galactic scale engineering. The more sensitive our instruments become, the more empty the sky appears. This creates a strange tension. The math suggests life should be common. The chemistry suggests it should be easy. The planets suggest it should have many chances to develop. Yet the observations suggest the opposite. The universe does not look crowded. It looks empty. This is where the mystery becomes sharper. Scientists gave this problem a name that sounds simple but carries deep weight: the Fermi paradox. The idea comes from a basic question asked by physicist Enrico Fermi. If intelligent life is common in the universe, then where is everybody? It sounds almost too simple, but it cuts straight into the heart of the issue. If even a small number of civilizations had developed millions of years before us, then space should not be quiet. A civilization with advanced technology could spread across a galaxy over long time scales. Not quickly, but steadily. Even at speeds far below light, the Milky Way could be crossed in a few million years. That is a short time compared to the age of the galaxy. So if others are out there, even a few, their presence should leave traces. Scientists often point out that we are not only listening for voices, We are also listening for footprints, signals, heat emissions, artificial structures, or patterns in starlight that do not match natural behavior. Even a civilization that does not want contact could still accidentally reveal itself through technology. Radio waves are especially important in this search. Earth itself has been broadcasting radio signals for a little over 100 years. These signals are already expanding outward at the speed of light. That means a sphere of Earth-made radio noise is slowly growing through space. Any nearby civilization could, in theory, detect it. Yet even after decades of scanning, no confirmed extraterrestrial radio signal has been found. There have been unusual detections, like the famous WOW signal in 1977. It was a strong, narrowband radio burst that lasted about 70 seconds. It has never been explained. It has never been repeated. But it also has never been confirmed as artificial. That pattern repeats across the search. Occasional mysteries appear. None hold up under repeated observation. Astronomers have also looked for physical evidence. Massive engineering projects on a stellar scale, sometimes called megastructures. One example often discussed in theory is a Dyson sphere, a structure that could surround a star and capture its energy output. Such structures would change how a star looks from Earth. They would alter its brightness in unusual ways. But despite careful surveys, no clear signs of such engineering have been found. Even more surprising is what we do not see in nearby star systems. If interstellar travel were common, there could be probes or signals scattered throughout the galaxy. Some scientists suggest that even simple self-replicating machines could spread from star to star over time. Yet our solar system shows no confirmed signs of any such visitors. This is where the Fermi paradox becomes difficult to ignore. The universe should have left clues by now, even small ones, even accidental ones. But the deeper we listen, the more uniform the silence becomes, a silence that feels too consistent to be random. When scientists try to solve the silence, one idea becomes both powerful and unsettling. It is called the Great Filter. The idea is simple in structure, but heavy in meaning. Somewhere along the path from simple chemistry to advanced spacefaring civilizations, there may be a barrier, a stage that is extremely unlikely to pass, a step that most life never survives. If this filter exists, it could explain everything. It could explain why life seems possible in theory, but invisible in reality. The first possible filter comes at the very beginning. Life itself may be extremely rare. Even though the universe is full of planets and organic molecules, the step from non-living chemistry to living cells might be incredibly difficult. On Earth, life appeared relatively early in its history, but that does not mean it is easy. It could mean Earth was unusually lucky. Some scientists point out that we still do not fully understand how life began here. The transition from simple molecules to self-replicating systems remains one of the biggest gaps in biology. If that step is harder than it looks, then most planets could remain lifeless forever. Another possible filter appears after life begins. Simple life might be common, but complex life might be rare. On Earth, for most of its history, life was single-celled. Complex organisms only appeared after billions of years. That delay could suggest that complexity is not a natural outcome. It could be an exception. Then there is intelligence. Even on a planet full of life, intelligence is not guaranteed. Earth has had millions of species. Only one has developed advanced technology. That alone raises questions. Intelligence may not be an inevitable direction of evolution. It may be a rare accident. But the most disturbing version of the Great Filter comes at the final stage. Civilizations might reach technology, but never reach the stars. They may destroy themselves before they spread beyond their home planet. This could happen through war, environmental collapse, resource exhaustion, or technologies that become uncontrollable. None of these require science fiction. They are extensions of real risks that already exist. There is a quiet detail often mentioned in discussions of this idea. On Earth, the time between the invention of radio communication and nuclear weapons was extremely short. Just a few decades separated the ability to broadcast into space and the ability to destroy civilization at scale. That kind of speed is unusual in evolutionary terms. If this pattern is common, then many civilizations could reach a dangerous stage at the same point. A point where their ability to expand is matched by their ability to self-destruct. This leads to the most unsettling possibility of all. The great filter may not be behind us. It may still be ahead. That means the hardest step in the journey toward becoming a long-lived space civilization has not yet happened for us. Or it is happening right now, quietly, without clear warning signs. In that case, the silence of the universe is not just about others. It may also be a reflection of a future that many civilizations never survive. Even if intelligent life exists, there is another hidden problem that could keep us alone. It is not just space, it is time. The universe is not only vast in distance, it is vast in history. It has existed for nearly 14 billion years. That is long enough for entire civilizations to rise and disappear many times over. But civilizations do not last forever. On a cosmic scale, even thousands of years is a brief moment. Even a million years is a blink. This creates a strange possibility. Intelligent life could exist, but not at the same time. One civilization could rise millions of years before another. It could develop technology spread across its region of space and then vanish long before a second civilization ever appears nearby. By the time the second one becomes advanced enough to notice, the first is already gone. This idea changes the way we think about silence. The universe may not be empty. It may simply be out of sync. On Earth, life has existed for over 3 billion years, but human technological civilization is extremely recent. Our radio signals have been traveling into space for just over a century. That means our entire detectable presence is almost nothing compared to the age of the galaxy. Now consider a different civilization. If it existed 10 million years ago in another part of the Milky Way, its signals may already have passed through our region of space. Or they may have faded into noise long before we had the tools to detect them. There is also a lesser-known detail in astrophysics. Star systems are not evenly distributed in time or space. New stars form constantly while others die. Planetary conditions change over billions of years. That means the windows for life to appear in different places may not overlap. A planet might develop life at the wrong time. Too early and the environment is unstable. Too late and the building materials for life may already be locked away in older systems. Timing becomes as important as location. Some scientists suggest that technological civilizations might be especially short-lived in cosmic terms, not because they cannot survive, but because the conditions that allow them to exist may be temporary. A stable climate, a stable star, and stable resources are not guaranteed forever. Even if civilizations do survive, communication across time becomes another barrier. Signals weaken, distances grow. Light takes thousands or millions of years to cross the galaxy. A message sent by one civilization may arrive long after it has already changed or disappeared. There is a deeper idea hidden in this. We may be looking for neighbors who are no longer where they once were. Or we may be the early ones waiting for others who have not yet arrived. Or we may simply be passing through a rare moment in galactic history where no other voices are active nearby. The silence in this case is not only about space, it is about timing. Even if intelligent civilizations exist at the same time, another barrier stands in the way: distance. Space is not just large. It is extreme in a way that reshapes communication itself. Even light, the fastest thing in the universe, moves slowly when compared to the size of a galaxy. A signal sent from one side of the Milky Way to the other can take tens of thousands of years to arrive. That means a conversation is not a conversation at all. It becomes a one-sided message stretched across generations. If a civilization is even a few thousand light years away, any signal we send today will take thousands of years to reach them. Their reply would take the same amount of time to return. By then, the original senders might no longer exist. This creates a silent delay built into the universe itself. There is also a lesser-known challenge. Space is not empty. It is filled with background radiation, pulsars, black holes, and natural radio sources. These create a constant noise floor. Any artificial signal must compete with this cosmic background. If it is not strong enough, it simply disappears into the noise. Even on Earth, early radio astronomy faced this problem. Weak signals were often lost or mistaken for natural interference. Now extend that challenge across the entire galaxy, and the difficulty increases dramatically. Another issue is signal decay. Over long distances, even organized transmissions spread out. They weaken as they travel. A strong, clear message becomes faint and scattered. At extreme distances, it becomes nearly impossible to distinguish from random noise. There is also the possibility that advanced civilizations do not use communication methods we understand. Humanity assumes that radio waves are universal, but that assumption may be limited by our own stage of development. A more advanced civilization might use entirely different forms of communication. They could use neutrinos, quantum effects, or something not yet discovered in physics. These methods would leave no trace in our current searches. There is another subtle point. Civilizations may also choose silence, not out of fear, but out of efficiency. Broadcasting across space may be wasteful or unnecessary for them. They might communicate in closed systems or within tightly connected regions without ever sending signals outward. There is even a possibility that large-scale communication is not done between stars at all. Civilizations may become local, focused on their own systems, with no need to reach beyond them. All of this leads to a quiet conclusion about distance. The universe may not be silent because nothing is happening. It may be silent because everything happening is too far away, too weak, or too different to reach us in any recognizable form. The silence of the universe is not simple. It is not a single answer. It is a layered problem built from distance, time, probability, and survival. Intelligent life may exist across the galaxy. In fact, many scientific models suggest it should exist. But each step from simple chemistry to advanced civilization may contain barriers that are far harder to cross than we once believed. Life may rarely begin. Intelligence may be rare. Civilizations may not last long enough to reach the stars. Even if they do, they may exist too far away or too far apart in time to ever meet. When all of these factors are combined, the result is a universe that could be full of life, yet still completely silent to us. That silence does not necessarily mean we are alone. It may mean something more complex. It may mean that life is scattered, separated, and isolated by forces we are only beginning to understand. The universe could be active but disconnected, alive but unreachable. There is a strange idea hidden inside this thought. The absence of contact is not proof of emptiness. It is only proof of separation. Across billions of years and billions of light years, countless civilizations could rise and disappear without ever crossing paths. Some may never develop technology. Some may never survive their own progress. Others may exist right now, but so far away that their signals will never reach us within the lifetime of the universe. This changes the meaning of the night sky. It is no longer just a view into space. It becomes a view into isolation on a cosmic scale. Not because life is absent, but because connection may be nearly impossible. And this leads to a deeper reflection. Humanity may be standing at a very early moment in a much larger story. A moment where awareness has just begun, but contact with anything beyond ourselves is still out of reach. The silence may not be empty. It may be crowded beyond recognition, filled with voices that never overlap in time or space. If that is true, then the universe is not asking whether life exists. It is asking whether life can ever truly meet. If you enjoyed this exploration of one of the deepest mysteries in science, take a moment to like the video and subscribe for more stories that explore the hidden structure of reality.